Okay. 5x to the fourth minus 20x squared equals 0. Just go ahead and write this down. 5x to the fourth minus 20x squared equals 0. Now that's not quadratic. Because quadratic, your highest exponent has to be what? 2. But it is a polynomial equation. And so remember last semester you had polynomials throughout. So this is a polynomial equation. Now, last semester when you factored the left side, what was the first thing you had to do? What was the first thing you had to do in factoring?
GCF.
The GCF. Very good. The GCF. So what's the GCF of 5x to the fourth minus 20x squared?
X squared.
X, 5x squared. 5x squared. So the GCF here is 5x squared. So 5 goes into 5, 5 goes into 20. And both of these have an x squared in common. And remember the GCF, when we talk about variables with exponents, you have x's here and x's here, right? The GCF, you always take out the one with the smallest exponent. So there are 4 here, 2 here. I take out how many? 2. So if you don't remember that, make sure you go to those videos. And there are some of you that need to, may need to review factoring. Okay, so the GCF is 5x squared. So then once you find the GCF, you're going to rewrite it as that GCF times what will give me this back.
X squared.
So 5x squared times x squared, yes, minus what?
4.
4, and that's it, right? Because 5x squared times a negative 4 is a negative 20x squared. But don't forget, that's also equal to what? 0. All right, so that's where I'm at. Now remember, the direction set's solved by factoring. So you got to remember the last semester you always told factor completely. What do you remember about x squared minus 4? Difference of 2 squares. So 5x squared times what? 2 binomials. What are those binomials? No, not plus 4 minus 4, because 4 times 4 is 16. Okay, no, that's fine. Just know that, though. All right, you agree it's this, right? Okay. Now, when you solved the equation by factoring last semester, what was the next step you did? The zero factor property. So you said each factor equal to what? 0. So zero factor property. So remember, the zero factor property says that if I have two or more factors whose product is 0, then one of them has to be what? 0. So all you do is set each one of these equal to 0. So you're going to get 5x squared equals 0. What's the next one? And the next one? Okay. Now I'm going to go to these two first. Those are the easier ones because those are linear. If x minus 2 equals 0, then what must x equal? 2. Okay, it's 2, right? If x plus 2 equals 0, then what must x equal? So those are two of my solutions. Now let's look at this one. Now, don't make this difficult because you can do this in your head. You can think about it. 5 times what number times itself is 0? 0. And if you didn't think about it that way, then remember that's x squared, right? So I could divide both sides by 5. Look what I'm doing. 5 divided by 5 is 1. 1 times x squared is x squared. What's 0 divided by 5? And then to get x by itself, right now I'm squaring. What's the opposite? Square rooting, plus or minus. And so I get x equal, what's the square root of 0? But positive 0, negative 0 is still what? 0. So there's your three solutions. But you really need to have seen that this was going to be a 0 because it's just a monomial. These are binomials, right? This is a monomial. So if your monomial contains the variable, then it has to be 0. Because 5 times 0 squared is still what? 0. So how many solutions are there? 3. So x equals 0, negative 2, and 2. Okay? Number 2. So solve by factoring. All right, number 2, you have 4x cubed minus 12x squared equal 9x minus 27. All right, now there's some stuff that you're going to have to go back and review. You're going to have to review all these. This is not easy for some of you. And you have to look at those videos. Now, what do you think I'm going to have to do number 2 first? Put in standard form. I want 0 on the other side. Remember, I want to solve by factoring, right? So if I'm going to solve by factoring, I've got to use the zero factor property. If I'm going to solve by factoring, I'm going to have to use what property? Zero factor property. It means I have to have one on the other side then. 0. So I've got to bring the 9x minus 27 to the other side. So if I do that, I'm going to get what? And put in descending order. 4x cubed. Okay. All right. Now, notice the difference between number 2 and number 1. Number 1, the first thing you have to do with factoring all the time is find the GCF. Number 2, what is the GCF of those 4 terms? No, I didn't ask that. I said, what's the GCF of those 4 terms? 1. No, there is. There's 1. 1, the number 1. So if 1 is the GCF, then you can't take out a GCF like we did in number 1. But you have 4 terms. What do you remember about factoring when you have 4 terms? Brian, you mentioned it. What did you say? I told you to hold up. What did you say? Grouping. You factor by grouping. So that's one of the things we talked about last semester, factor by grouping. All right, and for us, what usually worked was that we grouped which terms? The first 2 and the last 2. Factor by grouping. So first 2, last 2. So this is factor by grouping. Okay, factor by grouping. All right, so you can group the first 2, group the last 2. Now remember, you factor by grouping when you have those 4 terms. The GCF is 1, so I can't take anything out. Now, in the first 2, though, what is the GCF in the first 2 now? 4x squared. 4x squared is the GCF of the first 2. So if this part wasn't there, just like it did this, you would say 4x squared times what? Y'all agree it's x minus 3? 4x squared times x is 4x cubed. 4x squared times a negative 3 is a negative 12x squared. Okay? All right, now let's go to the next one. Now remember, if the third term is negative, you're going to take out what kind of factor? A negative factor. And the GCF here would be a negative 9. All right, now if I take out a negative, now remember, if you're doing this correctly, both of these in parentheses better be the same factor. So when I take out the negative 9 times what is a negative 9x? X. Negative 9 times what is a positive 27? 3. And are these correct? Yes. And that's equal to what, all this? So don't forget to equal 0. Now, so the first thing you had to do was group the first 2, group the last 2, take out the GCF from each group. Now you have this. Now what's the next step? No, not combine. Factor out the x minus 3. Factor out the x minus 3. So they both of these terms right here have an x minus 3 in common, right? You take it out. Now when I factor out the x minus 3, when I take this one out, what's left? Minus 9. So it's got to look like this, so that's how it's got to look. Okay? Now remember, just like with the first one, you factor completely. What do you notice about 4x squared minus 9? Difference of 2 squares. Difference of 2 squares. So I can factor this right here as how? 2x what? 2x what? Plus 3 times 2x minus 3. So difference of 2 squares. And you can always check yourself. 2x times 2x is what? 4x squared. A negative 3 times a positive 3 is a what? Negative 9. When I do the outer, what's the outer? And the inner? They cancel out, and that's what you wanted. You see there's no x term here. All right, now what's the next step?
Set it all to 0.
So zero factor property. So say each one of these equal to 0. So I'm going to set x minus 3 equals 0. I'm going to set 2x plus 3 equals 0. I'm going to set 2x minus 3 equal to 0. So over here, what's x? 3. Over here, I'm going to get 2x equal a negative 3. So what's x? Not 2/3. What's x? Negative 3 halves. Over here, I'm going to add 3 to both sides. I'm going to get 2x equal positive 3. So what's x? All right, so in the blank, you're going to say 3, comma, negative 3 halves, comma, 3 halves. So in the blank, you're going to say 3, comma, negative 3 halves, comma, positive 3 halves. Okay, so that was solving a polynomial equation. From last semester, you had to remember some stuff about grouping, and this is how you group them. And then you set each one equal to 0. Okay, let's look at this one. All right, and listen carefully to this one. All right, let's see if you remember something with this. Okay, so I have 3x to the 4th equal 81x. Write it out first. 3x to the 4th equal 81x. Okay, remember you want to solve by factoring. So if I'm going to solve by factoring, I better have what term on the other side? 0. So I got to rewrite this, put it in standard form or general form. What do I get? Right. Now before I go on, a mistake people make, see how both sides have an x? Mistake people make is they want to divide by x. You should never divide by a variable. Never divide by a variable. What happens when you divide by a variable, you lose one of your solutions. So never divide by a variable. Never divide both sides of an equation by a variable. Now you can divide by number. If I wanted to, could I have divided both sides by 3? Yes. You can divide by a number, you just can't divide by a variable. By a variable. Because that variable could be 0. So never divide by a variable. And remember, you can never divide by 0. Okay, so to be on the safe side, then I would just do this, bring everything to one side. Now, what's the next step? GCF. GCF. What's the GCF? 3x. Good. Times what? Nope. X cubed minus 27?
Yeah.
So x cubed minus 27. So remember last semester you talked about factoring the difference of 2 cubes and the sum of 2 cubes.
Yeah, I don't remember those, how that went.
Okay, so then what I need you to do is I need to go to Canvas, very bottom, or all the videos from last semester on factoring.
Oh, thank you.
Okay? So you need to look at that, some of these. So let's talk about how to factor the difference of 2 cubes, because that is the difference of 2 cubes. So the difference of 2 cubes looks like this. You have f cubed minus l cubed. That's the difference of 2 cubes. And so you can factor the difference of 2 cubes. When you factor the difference of 2 cubes, it's a binomial times a trinomial. A binomial times a trinomial. When you factor the difference of 2 squares, it was a binomial times a what? Binomial. The difference of 2 cubes is a binomial times a trinomial. All right, so basically the binomial is easy. You just read it as f minus l. There's your binomial. Now the trinomial is this. You take f, whatever f is. Now f stands for first and l stands for last here. So whatever your first term is in that parentheses, you're going to square it. You see how this is subtraction right here? You're going to do the opposite. So there's going to be a plus symbol then. And then you're going to take the first and the last, and you're going to multiply them. And then it's always going to be a plus, and then you're going to, oh, and then that, you remember how you square the first? The next one will be square the last, so it'll be L squared. So that's the formula for the difference of two cubes. The sum of two cubes is the same thing, except that the signs change. So the sum of two cubes, again, is a binomial times a trinomial. So if the difference of two cubes is f minus L for the binomial, then this one's going to be what? F plus L. And then everything's going to be the same except this sign right here. Remember how I had this arrow? So you're going to have f squared, but this is going to be a what? Minus, and then everything stays the same. FL plus L squared. All right, now, x cubed minus 27. X cubed minus 27. Now, I know it's the difference of two cubes. Remember when we talked about factoring the difference of two cubes, you asked yourself, if it is a difference of two cubes, then I can rewrite this as something cubed minus something cubed. I can fill in these parentheses. It kind of looks like this. I can fill in these parentheses. What times itself 3 times is x cubed? X. What times itself 3 times is 27? 3. So there's your F, and there's your L. So what is F here? X. What is L? 3. And all you do is use this formula. So this becomes your binomial. What's my binomial? X minus 3 times, and then this says here, this says I take whatever F is, what's F? X, and I do what to it? Squared. So that's going to be X squared. Plus, then this says I take F and L and I multiply them together. What's F? X, and L is 3, so I get what? 3X. Plus, and this says I take L and I multiply by itself. So 3 times 3 is 9. And there's this right here. Yeah, that's still there. Yes. Yeah. All I'm doing is just factoring this. So now I've got to go back and put all this stuff in here. So I get 3x times, and then we just factored this, so that's going to be all this, right? So that'll be x minus 3 times x squared plus 3x plus 9, and all that's equal to 0. Now let me mention this. Whenever you factor the difference of two cubes or the sum of two cubes, see this trinomial? You learn that you cannot factor that trinomial any further. All right, so don't try factoring this. It can never be factored. Okay, now this is where we at. Okay, so we factored out the GCF. We noticed that the binomial was the difference of two cubes. So I went to something I learned in the past, which were those two formulas, and I used them, and I get that. All right, now remember, the zero factor property says I take each factor and I do what? Set equal to 0. So I said those three things equal to 0, right? Okay, so listen carefully. 3x has to equal what? 0. So if 3x equals 0, then I know my solution x equal what? 0. So there's one of my solutions. You all agree? Because I could divide both sides by 3, right? All right. Now over here, x minus 3 equals 0. So what is x? 3. So far, my solutions are what? 0 and 3. All right, then I do the next one. What's the next one? X squared plus 3x plus 9 equals 0. Now notice, this is linear. This was linear. This is what? Quadratic. So how do I solve that then? I know I can't factor. Factoring is not going to work. Quadratic formula. So, yeah, so now you're going to use the quadratic formula. All right. So what is A? What's B? What's C? 9. So then I get x equal the opposite of B. So what does this become? Plus or minus the square root of 3b squared. So that's 3 what? Squared? Minus 4 times A. What's A? Times C, which is all over 2 times 1. All right. So then I simplify the discriminant. So I get negative 3 plus or minus the square root of, what's 3 squared? Okay, negative times a positive is a negative. 4 times 1 times 9 is 36, all over what? 2. Okay, so then we're almost done with this one. Negative 3 plus or minus the square root of a negative what? 27, all over what? 2. All right, so I'm going to get imaginary, right? Okay, now listen, you got to, my math lab, and on the worksheet, it's going to say to simplify this. So listen, the square root of negative 27, y'all agree that's I square root of 27? All right, now let's simplify the square root of 27. What perfect square goes in 27 besides 1? 9. So that's I square root of 9 times 3. And what's the square root of 9? So what does this become? Yeah. So 3I squared root of 3. And so that goes here. So your answer is this. Negative 3 plus or minus 3I square root of 3 all over what? 2. And I can't simplify this because 3, 3, and 2 have what in common? No, don't say nothing. 1. All right. So my solutions are, how many rational solutions do I have? No. 2. A 0 and a what? A 3. And also have what kind of solutions? To imaginary. All right. So in the blank, you'd say 0, comma, what's the next one? 3, comma, what's the next one? Negative 3 plus 3I square root of 3 over 2, comma, negative 3 minus 3I square root of 3 over 2. So you had how many solutions altogether? 4. It's just a lot of work.
It is a lot.
I know, but you're going to study it.
Just putting that answer in my math lab takes like 5 minutes.
I know, when you do my math lab.
You're just typing it in like.
Yeah, when you do my math lab, remember, especially those that had this last semester, you got to go to the blank, and then you got to punch in that fraction bar, right?
Yeah.
And then you do the numerator, and then you do the denominator. Huh?
What you talking about? I figure out what the little code is for that hotkey and I punch it in.
Okay.
I ain't got all that time to be looking.
All right. Okay. So that was a lot of work. So notice you put in standard form, then you found the GCF, then you factored the difference of two cubes, some work you had to do there, then you put that here, then you said each factor equal to what? This was linear, but this was what? Quadratic. So you had to use quadratic formula because you knew we could not factor this. And that's what you had. Okay? All right, what time is it?
9 o'clock.
No, it's not.
8:37.
All right.
Did you give us you were missing a worksheet last week.
I don't think I gave it to you yet.
Okay.
Yeah. It's up here. Okay, now, look at this. All right, listen carefully. Okay, so you know that if you have x plus 4 squared equal, let's say, 6, what y'all do to solve? Square root, right? And then that was a plus and minus, correct? So the square and the square root don't do each other, so you said x plus 4 has to equal plus or minus square root of 6? Y'all agree? All right, now this is irrational, correct? So my answer then would just be what? X equal what? Negative 4 plus or minus square root of 6. Okay. Now, in my math lab, you'd break it down to two solutions. All right, now what if we had this now? Now, last semester, this is the one you had. You had something like this. You had square root of x plus 5 equal, let's say, 2. Square root of x plus 5 equal 2. So you want to solve this. You would, right. So right now, we're going to solve for x, right? So right now I'm taking the square root So the opposite of taking the square root is to raise both sides to the second power. So remember, what is the index right there? Remember the index? Right. So if I had the cube root, fourth root, fifth root, what are your indexes here? This one, 3. Your index here is 4. Your index here is 5. So what's this index right here? 2. There's no number there, so this is to be a 2. That's why it says square root. So to solve a radical, now these are called radical equations, because you have a square root, cube root, fourth root, and so on. Those are radicals. To solve a radical equation, you're going to raise both sides to a power that's equal to the index. So what's my index here? 2. So you're going to square both sides. If this were cube root, you would raise both sides to what power? The third. If this were fourth root, you raise both sides to the fourth, and so on. But we're only dealing with square roots in here. Now the other thing you remember, you had to get the square root by itself. Is the square root by itself? Is the square root expression by itself? Yes. So in other words, if I had this, square root of x plus 5 minus 1 equal, let's say, 5, is a square root by itself? No. You would have to add 1 to both sides. All right? So once you get the square root expression on one side by itself, then that's where you raise both sides to the second power. So you're going to square both sides. No. The only time you do that plus or minus is when you take the square root of both sides, or the even root of both sides, or the fourth root, sixth root, and so on. Here you're squaring, so that's not the plus or minus. All right. So when I square, the square and the square root into each other, so you get x plus 5 equal what? 4. So notice I went from a radical equation to what kind of equation? Linear. So then I solve for x, and so what's x here? -1. Now that's what you talked about last semester. So last semester you talked about radical equations where on the left side you had a square root, on one side you had a square root, on the other side you had a number. So when you raise both sides to even power, you end up with a linear equation. Okay? Now let's look at this one. Watch this. So suppose we had this. The square root of 20 minus 8x equal x. Notice the difference between the two. What's the difference between this one and, let me go back and just put it here, the other one we had? Yes, so there's a variable on the other side instead of a number. So let's see what's going to happen. All right, first of all, is the square root expression by itself? Yes. So what should be the next step? Square both sides. So I'm going to go ahead and rewrite it. Okay. I'm going to square both sides. Just like that. The square and the square root undo each other. So what's left? Okay, so that's where I'm at, right? So when I did the previous one, when I squared both sides, I ended up with what kind of equation right here? Linear. Here I ended up with what? Quadratic. So I end up with a quadratic equation. And so if I have a quadratic equation that looks like this, what should I then do? No, you're going to use a quadratic formula. I wouldn't complete the square in these. The only time I would complete the square is if I was told to complete the square. Y'all agree it's easier to use a quadratic formula, right?
Yes.
Than it is to complete the square.
Yes.
So if I have this quadratic equation, then I'd want to use quadratic formula. If I'm using quadratic formula, then I have to have 0 on the other side.
Yeah.
Now x squared is on the right side, so let's bring everything to the right side. So I get 0 equal x squared, and tell me the rest. Put in descending order. Not plus 8x minus 20. So put in descending order. So x squared. So when I bring the negative 8x over, it becomes positive 8x. When I bring the positive 20 over, it becomes a negative 20. All right. Now, if this right here, you can factor that, but for some students, it takes a while for them to, if it is factorable, to actually figure it out. So what should you always do if you have that issue? Quadratic formula. Let's use the quadratic formula. What's A? 1. What's B? What's C? Okay. So I get x equal the opposite of 8, which is negative 8, plus or minus the square root of b squared. So that's 8, right? Squared. Minus 4 times A. What's A? Times C. All over what? 2 times 1. Okay. So I get negative 8 plus or minus the square root of, what's 8 squared? Not 9 and 1. 8 times 8 is 64, right? Guys, I don't want to bring some timetables in here to hand out to y'all. All right. A negative times a positive times a negative is a positive. 4 times 20 is 80. All over what? Not negative 80, positive. You see how some of you are messing up on these? You got to be careful. What's 64 plus 80? 144, right? All over 2. Is 144 perfect square? Yes. So my discriminant is positive, so I'm going to get 2 what? What kind of solutions? 2 rational. All right, so square root of 144 is 12, correct? Since I got 2 rational, you're going to split it apart. So I get negative 8 plus 12 over 2, and what's the other one? What's negative 8 plus 12?
4.
And what's 4 over 2?
2.
Okay. All right, 2. Over here, I get negative 8 and a negative 12 is a what?
20.
Negative 20 over 2, which is
Negative 10.
negative 10. All right, now listen carefully to this. Okay, so you squared both sides.
Oh, wait. Oh, sorry.
I mean, there wasn't anything there. You always, okay. All right, so you're going to square both sides, right? Then when you square both sides, you ended up with a quadratic. Then you solve the quadratic using a quadratic formula. So there's all your work. Okay, now listen. If I plug in 2, if I check, let's just check this. If you check, let's say 2, let's check our answers. So check x equal 2. Now, whenever you check your solution, always go back to the original because you could have easily messed up along the way. Always go back to the original. So my original was this one right here. Y'all agree? So I'm going to go ahead and just rewrite it. So this was my original. Okay, so wherever we see an x, what am I going to plug in? 2. So I'm going to ask myself, is the square root of 20 minus 8 times 2 the same as what? 2. Using the order of operations, what's 8 times 2? And what is 20 minus 16? And what is the square root of 4? And so they're equal, correct? Y'all agree? All right, let's check this one. Go back to the original. Here's the original. Okay. Oh, I'm sorry. Excuse me, that was not a 2. Excuse me, that was a what? That was the original was not a 2 right here. It was a what? No. It was x. Excuse me. I messed up. But I plugged in what? 2. So this is x, right? Okay. So wherever we see an x, what do I plug in? Negative 10. All right. Listen carefully to this. Square root of 20 minus 8 times a what? And I want to see if that's going to equal a negative 10. No, x is negative 10. Well, what is a negative 8 times a negative 10?
80.
So I get the square root of 20 plus 80, correct? What's 20 plus 80?
100.
And what's the square root of 100?
10.
Is 10 equal to negative 10? No. So x equal negative 10 is not a solution.
So you have to check both.
No, well, yeah, you do. Okay. Well, You really don't, but if I tell you why, you're going to get confused. So just go ahead and check both. Okay, so whenever you raise both sides to the even power, whenever you raise both sides to the even power, when you raise both sides, God, Lord, I'm messing this up. When you raise both sides, Lord, when you raise both sides of an equation to an even power, and I did because I raised both sides to what power? The second. You might introduce what's called extraneous roots or solutions. Another word for a root is a solution. So when you raise both sides to an even power, you might introduce extraneous roots. Extraneous meaning false solutions. So what happens is this. 2 and negative 10 are solutions. They're solutions to this quadratic. If you plug in 2, this size equals 0. If you plug in negative 10, watch. What's negative 10 times itself? 100. What's 8 times a negative 10? What's 100 and a negative 80? Negative 20, positive 20. What's a 20 and a negative 20? Is 0 equal to 0? Yes. So 2 and negative 10 work here, but negative 10 does not work in the original. So that's why it's called a false solution. It's a false solution because it satisfies one of these equations right here, but it doesn't satisfy the original. So this one right here is called an extraneous root. But in the blank, you're only going to put x equal what is the answer? 2. X equal 2. So one of your worksheets, you're going to have one where you're going to have an extraneous root. Now, we're not done with this section, so I'm going to come back and do another one with it. So let me go ahead and give you the worksheets that goes with this. So again, we're not done with this section.